Today's lessons, lesson 4, found on pages 12 and 13 of our textbook. Basic exponent properties. Exponents, also known as powers, represent repeated multiplication. For example, x to the fourth is equivalent to x times x times x times x. 7 to the third is equivalent to 7 times 7 times 7. And 5 squared a to the third b would be equivalent to 5 times 5. A to the third would be a times a times a, and b would be times b. It's important to remember that when you're multiplying monomials, we multiply the numerical coefficients and add powers of like bases. For example, to find the product of monomials negative 2x to the fifth and 4x squared, product is result from multiplication. Negative 2x to the fifth times 4x squared. We multiply the numerical coefficients. So negative 2 times 4 is a negative 8. And then we add powers of the variable bases. So x to the fifth times x to the second would be x to the 5 plus 2, or x to the seventh. So negative 8x to the seventh. Explain why the final exponent on the variable x is 7. Well, it's in our, because you add the exponents. When we multiply same variable bases, we add the exponents. So let's practice multiplying monomials. 5x squared times 3x to the 6. We'll multiply the coefficients. 5 times 3 is 15. And x squared times x to the 6 would be x to the 2 plus 6, which is x to the 8th. So 15x to the 8th. Negative 2x times negative 6x to the 4th. We multiply the coefficients. Negative 2 times negative 6 is positive 12. X to the first times x to the 4th is x to the 1 plus 4. So 12x to the 5th. C, 3 halves x to the 4th times 6x to the 10th. We take our 3 halves times our 6, and it might be helpful to put the 6 as a fraction, 6 over 1. And when we multiply fractions, you multiply numerators. 3 times 6 is 18. And you multiply denominators. 2 times 1 is 2. 18 divided by 2 is 9, so that reduces to 9. And now multiplying our variable bases, x to the 4th times x to the 10th is going to be x to the 4 plus 10, which is x to the 14th. So we have 9x to the 14th is our result. For D, we have 4x to the 3rd squared. Okay, so this means 4x to the 3rd is being multiplied by itself. So this is equal to 4x to the 3rd times 4x to the 3rd. Now 4 times 4 is 16. X to the 3rd times x to the 3rd is x to the 3 plus 3 is 6. And just remember, monomials can have more than one variable. So exercise 2 asks us to find each of the following products which involve monomials with multiple variables. 4x cubed y squared times 5xy to the fifth. We will take our coefficients here. 4 times 5 is 20. And then our same variable bases, x to the third times x is x to the 3 plus 1 is, I'll leave it 3 plus 1 for now and simplify the next step. Y to the second times y to the fifth is y to the 2 plus 5. So our final answer is 20, x to the fourth, y to the seventh. B, negative 2 times negative 4 is positive 8. X to the seventh times x to the second is x to the 7 plus 2 is 9. And y to the third times y to the sixth is y to the 3 plus 6 is 9. For C, and with these fractions, 1/2 times 5/2. You multiply numerators. 1 times 5 is 5, and 2 times 2 is 4. With same variable bases, x times x squared, that's going to be x to the third, right? We add 1 plus 2, and y times y to the fifth would be y to the sixth. That is our answer. D, again, just two monomials that we need to multiply. So coefficients 2/3 times, I would write -5 if it's -5/1. 2 times -5 is -10. 3 times 1 is 3. Now a to the third times a to the third is going to be a to the sixth. And b to the fifth times b to the second is b to the seventh. So -10/3, a to the sixth, b to the seventh. Now in E we have 3 monomials, 1, 2, 3, but this last one here is being squared, so we need to do that first. So let's just rewrite this as 5a squared b to the third times 5a squared b to the third, right? Because that's what 5a squared b to the third squared gives us. And let me bring down the other first 2 monomials. Okay, so now we have 4. That's all right. We'll just multiply the coefficients first, right? -4 times -1 is +4. Times 5, let's see, +4 times 5 times 5. That's 20 times 5 is 100. So that's a coefficient. Next, same variable base. Let's go with a to the first times a to the first is a to the second times a to the second times a to the second. Or let me do this. Let me write this as a to the 1 plus 1 plus 2 plus 2. That is a to the sixth. And b to the second times b to the first times b to the third times b to the third. So that would be b to the second plus 1 plus 3 plus 3, which would be b to the 9th. So this is our result. Okay, next we want to kind of start with an end result and go backwards. So we want to fill in the missing blank in each of the following equations involving a product such that the equation is an identity, right? Such that the left-hand side is going to equal the right-hand side. Okay, so our blank is here on the right-hand side. So let's start with the right-hand side, and we want to say to ourselves, 2x squared times what? It will equal 6x to the fifth. So 2x squared times what would equal 6x to the fifth? Well, let's go with the coefficient 2 first. 2 times what? 2 times 3 would result in 6. And now our exponent, our variable base x, we have x squared. X squared times what is going to give us x to the fifth? It'd be x to the third. So we replace our blank with 3x to the third. Then let's just check this, right? If we multiply, 2 times 3 is 6, and x squared times x to the third is x to the fifth. B, start on the right-hand side. 4 times what gives us 12? 4 times 3 gives us 12. And then x to the third times what will give us x to the eighth? X to the third times x to the fifth. So 3x to the fifth belongs on that blank. C, -2 times what will give us 20? -10. X to the first times what will give us x to the second? Another x to the first. And y to the third times what will give us a y to the fourth? We need a y to the first. So -10xy. Exercise number 4 asks us to use our distributive property. 4a, we have 2x times 5x plus 3. We take our 2x and distribute it over our parentheses. 2x times 5x is 10x squared, and 2x times +3 is a +6x. B, we have the monomial 5x cubed times a trinomial, 3 terms. 5x cubed times 2x squared, 5 times 2 is 10, x cubed times x squared, x to the fifth. Simple. 5x cubed times -3x, 5 times -3 is -15, x cubed times x to the first is x to the fourth. And 5x cubed times a +6, 5 times +6 is +30. Carry over the x cubed. C, distributing the -7x squared over the parentheses. Again, another trinomial inside parentheses. -7 times +1 is -7. X squared times x squared, x to the fourth. -7x squared times -2x would be a +14 x cubed, and -7x squared times a +3 is -21 x squared. D, distributing xy squared over the binomial. Xy squared times x squared, well, x to the first times x squared is x to the third. Carry the y squared, and then xy squared times -y squared, -x, y to the fourth. E, distributing 3x squared y to the fourth over another trinomial. That's 3 terms inside parentheses. Three times 2 is 6. X to the second times x to the second is x to the fourth. y to the fourth times y to the first is y to the fifth. Three times 1 is positive 3. X squared times x to the first is x to the third. Y to the fourth times y to the second is y to the sixth. 3 times negative 4 is negative 12. X squared times, there's no other x variable there, so we just bring over the x squared. And y to the fourth times y to the third is y to the seventh. And then for exercise number 5, we're going to do like we did in exercise number 3 at the top there, which was fill in the missing blank that will make the equation an identity. So we're saying to ourselves here, looking on the right-hand side, 4x times what is going to give us 8x squared? Well, 4x times 2x gives us 8x squared. And 4x times what will give us negative 12x? 4x times negative 3 would give us negative 12x. So 2x minus 3 belongs inside the parentheses. B, 7x squared times what gives us 7x to the fourth? Well, we need an x squared. 7x squared times what will give us negative 21x cubed, negative 3x. And 7x squared times what will give us negative 28x squared, negative 4. So the trinomial x squared minus 3x minus 4 belongs in that parentheses. C, 5x squared y times what is going to give us 10x cubed y squared? Well, 5 times 2 will give us a 10. X times x squared gives us x to the third. And we already have the y squared. So it's just 2x squared. Next, 5xy squared times what is going to give us negative 20x squared y to the third. 5 times negative 4 will give us negative 20. X times x would give us x squared. And y squared times y to the first would give us y to the third. And 5xy squared times what is going to result in 35xy to the fifth. That would be a positive 7 y to the third. And this last one looks a bit more complicated. Well, let's look at the right-hand side. We have x minus 2. Okay, so x minus 2 times what would give us? All right, now looking at the left-hand side, we actually have just two terms. This is one, and this is the other. So x minus 2 times what would result in 4x squared times x minus 2? Oh, well, that's simply we need the 4x squared. And x minus 2 times what would give us negative 9 times x minus 2? It would be simply the minus 9. That concludes today's video. Thank you very much for your attention.